A solar furnace is a structure that uses concentrated solar power to produce high temperatures, usually for industry. Parabolic mirrors or heliostats concentrate light onto a focal point. The temperature at the focal point may reach 3,500 degrees Celsius, and this heat can be used to generate electricity, melt steel, make hydrogen fuel or nanomaterials. The largest solar furnace is at Odeo in the Pyrénées Orientales in France, opened in 1970. It employs an array of plane mirrors to gather sunlight, reflecting it onto a larger curved mirror. History. The ancient Greek, Latin term heliocamenus literally means solar furnace, and refers to a glass-enclosed sunroom intentionally designed to become hotter than the outside air temperature. During the Second Punic War, the Greek scientist Archimedes is said to have repelled the attacking Roman ships by setting them on fire with her burning glass that may have been an array of mirrors. An experiment to test this theory was carried out by a group at the Massachusetts Institute of Technology in 2005. It concluded that although the theory was sound for stationary objects, the mirrors would not likely have been able to concentrate sufficient solar energy to set a ship on fire under battle conditions. The first modern solar furnace is believed to have been built in France in 1949 by Professor Félix Trombe. It is now still in place at Mont-Louis, near Odeo. The Pyrenees were chosen as the site because the area experiences clear skies up to 300 days a year. Another solar furnace was built in Uzbekistan as a part of a Soviet Union Sun complex research facility impulsed by academician S.A. Asimov. Uses. The rays are focused onto an area the size of a cooking pot and can reach 4,000 degrees Celsius, depending on the process installed, for example, about 1,000 degrees Celsius for metallic receivers producing hot air for the next generation solar towers, as it will be tested at the Themis plant with the Pegasus project. About 1,400 degrees Celsius to produce hydrogen by cracking methane molecules. Up to 2,500 degrees Celsius to test materials for extreme environments such as nuclear reactors or space vehicle atmospheric re-entry. Up to 3,500 degrees Celsius to produce nanomaterials by solar-induced sublimation and controlled cooling, such as carbon nanotubes or zinc nanoparticles. It has been suggested that solar furnaces could be used in space to provide energy for manufacturing purposes. Their reliance on sunny weather is a limiting factor as a source of renewable energy on Earth, but could be tied to thermal energy storage systems for energy production through these periods and into the night. Smaller scale devices. The solar furnace principle is being used to make inexpensive solar cookers and solar-powered barbecues, and for solar water pasteurization. A prototype Scheffler reflector is being constructed in India for use in a solar crematorium. This 50 square meters reflector will generate temperatures of 700 degrees Celsius and displace 200 to 300 kilograms of firewood used for cremation.